So awesome. I will start off. That's me in a nutshell. Real quick, I got my bachelor's degree at Utah State University. It's in northern Utah, and I got my bachelor's degree in environmental engineering. I was in Alaska for one of my first jobs, and I got my master's degree in civil engineering up in Alaska, and did some really cool research up in there. And currently, I'm getting my PhD here in Ohio at the Air Force Institute of Technology. So, and that's in systems engineering. So, kind of had my spread across the spectrum of different things. But I absolutely love STEM. I love it. It is something I'm passionate about, something that I love to talk to people about and explain why it's so important that we get it integrated into our curriculum, but also that you as an individual, you can do something in this field if it's something that you enjoy. And you shouldn't be scared or intimidated by some of the things that are some of those prerequisites you have to jump over. Like, for instance, people I love STEM, but I have a hard time with math. It's okay. If that's your question, let's talk about it, and we can go there. But first of all, I'm going to share my screen and introduce 3 disciplines of engineering that I'm pretty familiar with, and I feel very comfortable going any way you want to go as a class. So we'll jump there real quick, and then we'll try to use our time efficiently so that you guys can all of you can ask your questions. Okay, so you should see a blank screen, nice white screen here. So the first discipline of engineering I want to talk about is civil engineering. Now, I think you've covered that in your class already. So as you've covered that, there's lots of different aspects of civil engineering. For instance, there is water resource engineering. Let me use real quick. I'm going to use a little laser pointer here. So this top one here is water resources and environmental engineering. Then there's construction projects and management. Geotechnical deals with everything that's below the ground. So for instance, just real quick, we land airplanes in the Air Force on the runway. Well, all that pavement and everything that's happening under the ground, I have to understand what's going on down there and how it's all going to interact with that aircraft to make sure I provide a good landing surface. Structural engineering, that's buildings and high rises and anything that's structural designs, making sure that it's strong enough to withstand the elements that it's going to be put up against. Transportation engineering is all about the roads. You probably went to school, or if you're not at school, if you're at home, then you probably didn't go out today and enjoy the transportation we provide. But the roadways and all the planning and all the systems there for freeways and highways. Then there's a thing called surveying. Surveying is all about understanding heights and elevations, lengths, cuts, distances, and those types of things. So really cool stuff with that as well. So the next discipline of engineering is called environmental engineering. Environmental engineering has a lot of different things as well. So with that, there is water engineering. So that's providing you drinking water. If you've had a drink of water today, that's something that we're involved with to make sure that you have drinking water. Then we also take care of it from the other end. If you've gone to the bathroom today, we've taken care of that wastewater. And that's something we have to think about of how we're going to take care of this to make sure that we can continue to sustain this type of life that we're living. Then we also have natural systems, rivers, lakes, all that kind of stuff. So we deal with that, making sure that that's taken care of. Got some cool stories there if you want to hear. Remediation. So when we have done things in the past and maybe spilled oil or spilled toxins that have gone down into the groundwater, we call this type of thing remediation. So environmental engineers work on taking what's underground and cleaning it so that it doesn't impact people. Again, other cool stories there if you want to go there. Solid and hazardous waste. This is your garbage. So today we have our garbage truck pickup here, my part of Ohio, and that all is planned and done by environmental engineers. And then we also have air quality, the air you breathe. All of that has to be thought of as we're kind of thinking about industrial systems and cleaning up waste products from the stuff that we do in order to live. So that's environmental engineering. So we got civil, environmental, And the last one I want to talk to you about is military engineering. People are like, military engineering, that's a discipline? It is. And what we do is we have 3 different big elements. So we deal with combat, and there's things where we have to have confrontation with other people, and that requires engineering. Requires engineering in order to get places, mobility, or to stop people from getting to us. That's counter mobility. And then we also want to be able to survive if we're in combat, and that's called survivability. So that's kind of the combat side. Then there's general engineering, very similar to the civil and environmental stuff that you see. We're dealing with construction, sustainment, we're modifying buildings and or infrastructure assets. So all of that's encompassed in that general. That kind of pulls in both of those, that civil and environmental, and pulls it into that military aspect that we have to deal with as uniform wearers. And then we have a geospatial side of engineering. And that is really all about more so to the surveying piece, but we start to do it with satellites and with GIS, with computer programs, and really trying to figure out what's going on. So with that, those are the 3 aspects that I'm really comfortable to jump to. And I want to know what you want to talk about as a class. So do you want to talk about civil, environmental, or military? So I'm going to pause real quick. So that's 1, 2, or 3. And either you can throw in the chat function, you can talk about it in your group. I'll give you just a little bit of time. Why don't you talk about it and then throw in the chat or somewhere so that we can figure out what you want to talk about. So again, civil is number 1, environmental is number 2, military is number 3. So I'm going to stop sharing so I can kind of see you all. You can either hold up your fingers or type it in the chat. I think it'd probably be easier if you put it in the chat, but we'll go from there. Cool. Dominic's is really interested in military engineering. So it's a unique thing, and it's something that we don't get to hear about a lot. Probably in your class, you've gone through mechanical engineering, electrical engineering. My guess is you'll probably hit a couple others that are pretty common: computer engineering, maybe chemical engineering, civil engineering. I think you've covered civil engineering. I don't know if you've really covered environmental. Have you? Okay, cool. And then military engineering is one you're probably not going to cover. It's just not typical, okay? But it sounds like there's an interest there. So we'll dive into that. We'll go into specifically military engineering. To start things off, I want to tell you about a really cool experience I had, okay? So let me jump back here, share the screen again, and we will jump forward. Okay, so come in here. I want to jump to this one right here. Okay, this is a picture of when I was actually down in Honduras. This is not me, obviously, but I actually, as part of the military, we go all around the world. And one of the places I was blessed to go was down to Honduras. That's in Central America, kind of in the peninsula, the lower end of North America, right before you head into South America. Beautiful place. Tropical almost in some sense. There's mango trees growing all over the base there. It's actually a Honduran Air Force base, and the Hondurans own it and operate it. And we just are there supporting them. We do a couple different missions there. And one thing I want to bring up to you as we start to talk about military engineering and these aspects of combat engineering, general engineering, and geospatial engineering, there's also a piece that we do where we give back to society. And that's kind of not written down anywhere, but it's a big piece of what we do as engineers. As you think about an engineer in terms of civil, that's creating civilization. It's all about people. And this picture, I think, encompasses that for me. So in Honduras, every single weekend, we as members of the military would go off the base, the installation there, and we would go work with the local communities. We would go visit orphanages. We would go build homes for them. So we actually undertook projects and we built people houses. We took brick and mortar and we basically built them houses from the ground up. And it was wonderful. So I'm used to I can call up somebody and get an order of cement mix to come pour something, like if we're going to pour a runway or something. I just call that in, schedule it, and have them come. Here in Honduras, we had dirt, we'd had sand that we'd put on the ground in these rings. We would dump cement bags into the middle of them, and then we'd pour water. We'd grab buckets of water from a barrel and haul it over, do like a bucket brigade of like handing buckets down a line, pour the water in, and then we would take shovels and hose, and we would sit there on the ground and mix the concrete that we would then use for the house. I mean, just a really cool experience going back to, this is just how you can do it. And just an awesome experience in a way that I, as an engineer, as someone that deals with construction and management, could give back to the society that I was there for. So something really cool that we get to do as engineers that a lot of people don't realize or know about. There's a lot of people in this world that don't have what we have, or don't have even the basic necessities of life: clean water, a shelter to cover your head. And so being able to give that back to people was absolutely fascinating. So that's a piece that I attach to military engineering, because in that context, I have done that all around the world. When I was in Alaska, we actually sent people to the Philippines to build schoolhouses and to do electrical work for them, and to do some painting and reconstruction of some abandoned or buildings that weren't doing very good. And so that's just what we do. It's part of our mission set, is giving back to people. And the reason why we do that as the military is we want friends, not enemies. If anybody in the entire world doesn't want conflict, it's the people that have to fight in that conflict. And so when we can do things that build relationships, that build trust, that build partnerships, those are all things that are wrapped into that idea of military engineering. Now, there are times when we can't do that, right? So there are times when we're going to have to make some decisions that are a little tough. Let me stop sharing real quick. Okay. And so what I want to tell you about is this combat side, okay? Mobility, counter mobility, and survivability. So here's how this works. Let me give you an example of each one of these, and that kind of will help you understand what it means to be an engineer in this context. So combat engineering, typically the people that do this really good is Army and the Marine Corps. Now, I'm in the Air Force, and we don't do a lot of this, but combat mobility engineering is all about getting over obstacles. So here's an obstacle. You come up, you're in a convoy, you have some tanks, you have some logistics, some things some supplies that you're taking to somewhere, and you hit a gap. A gap could be a cliff, and then another cliff on the other side. It could be a river. How do we get across it? How do we get across it quickly? And how do I carry tanks across that? I can't just throw down some planks of wood and walk across it. That's just not going to work to drive a tank across. So we use equipment. We use all sorts of cool engineering capacities. So we look at the soil on the close side, and I say, can it withstand? Is it strong enough for me to load it, to put something heavy on it? So you got to think about this. If I've got two pillars, two sides of this cliff, all right, I got my pens here. These are my cliffs. So you got to bear with me here. All right. And I'm going to put something over the top of that. What we have is we have a truck that drives up, and we unfold it, and it lays down a bridge on top of that. So it covers the gap, and then we can drive across it. That's gap crossing. There's all sorts of different aspects of that, but that's something that we have to be able to do as engineers. Here's another cool one. We come up to a river. We have floating bridges that we can then connect piece by piece. And so we have these engineers that they go out and they get the first piece out there, they put the next piece out there, and they start driving onto this floating bridge, putting piece after piece after piece in front of them. That's mobility, being able to overcome obstacles, wanting to get from point A to point B. And that requires engineering judgment, it requires skills. So we train like that. We train, the Army especially and the Marine Corps train like that. If they want to get troops from point A to point B to help somebody, to rescue somebody, to recover somebody, or to attack somebody, all of that requires mobility. And so that's what you do in terms of mobility. Now, if we have a roadway coming into our base, and I don't want bad guys to come into that place of protection where I've kept people that we love and cherish, or things that we want to protect. Okay. If we want to keep people out, we have to think about, how can I stop people? So again, real quick in the chat, why don't you throw down some ideas of how you would stop somebody? So say somebody's trying to come into your base, into your house, into your school. Think about your high school. What have you done to keep people out? Can anybody drive right into your school? What has stopped them? So think about that real quick, and then you can type in the chat what your ideas are. I like it. Somebody put a wall. Excellent. Walls are definitely helpful. Could they drive into a wall? Or what stopped them from driving into the wall? Has anything? Maybe not. A speed bump? That definitely slows them down normally. Perfect. So somebody put ID cards, right? So being able to check and to verify, that definitely would slow down a process. When we think about engineering, we typically think of like solutions. So who's ever seen, maybe you don't know this word, bollards? They're like concrete pipes that come up about the height of your waistline, maybe higher, it depends. But they're stuck in probably every 2 feet or so. So you can walk through them, but nothing could drive through that. Has anyone seen anything like that before? Bollards. Who's ever seen the Jersey barriers? They're the cement walls, the little wall segments you see along roads sometimes. If you've seen those, they could place those out in front of buildings that blocks people. If you ran into that, it would likely damage your vehicle more than it would damage the block. Okay. Especially if we think through this, hey, well, somebody could have a really strong truck with a ramming apparatus, and they can hit that thing and blow it out of the way. So what we do is we tie it with a really strong cable to each and every single one in a line. Then instead of dragging one or blowing away one, I have to blow away 10. Always, that makes it a little more harder. And so we think about these things in terms of counter mobility. How can I stop people from getting from point A to B? So mobility is thinking about, I want to get from A to B. Counter mobility is thinking about, I want to stop you from going from A to B, or from going from B to A, whichever way you want to think about it. Okay, so that's combat engineering in a general sense. There's one more piece, survivability. I wish I had a cool picture of this one. But as you think about survivability, there's a few things that we have to take into consideration. One, people want to hurt what you're building. Okay, and as a civil engineer, as somebody that builds stuff, I have to think about that. Somebody may want to destroy what I'm building, so I have to make sure it's really strong. Okay, and there's something that we do called hardening. Now, this is specifically kind of tends back to, let me think about what time we had here. This gets over at 10:20, right? Okay, just want to make sure. All right, so hardening is really about trying to make sure that this building, if it was subject to a blast, say a bomb or something like that, I have to think about what's going to happen to that building, and can I still keep it up? The last thing I want is for that building to explode or to be hit and then to collapse. Maybe some of you, my guess is you probably weren't born when September 11th happened. So what ended up happening there is there was an explosion in the building, and then the entire high rise came crashing down. We can think of that as progressive collapse. There's lots of different things that happen with that. That is a hazard for sure. I want it to be able to withstand an impact and to remain standing so that I can take it down when I want to, and not for it to come crumbling down. So I have to harden the building. I have to think about where are the likely points that it could get hit, and then how is it going to withstand that? So that's all about survivability. I want to think through, okay, I'm going to be hit. I'm going to receive damage. How do I make sure that I strengthen this building or create places in the building that are extremely good and protected. Now, who's ever seen any of those movies where people go like stories underground? Seen those movies? Yeah, we have those places. We really do have those places. They exist. Lots of them exist across the world, and there's a reason why. And why do you think that is? Somebody can chime in. They can go for it. I see I think it's Elijah. That's what the name I'm seeing. Go for it. Why don't you unmute yourself?
So like if the building were to collapse, there's like an underground bunker where people can go so nothing bad happens.
Absolutely. Right. And when we think about explosions or propagations, it's going to get significantly dampened. That effect will be less and less and less the farther I go underground, right? Now, to combat that, people create then weapons that go farther in ground and then explode. So it's always this give and take. What's the threat? What do I need to do to survive that? Okay. But we do have those locations. They are important. And back when we lived in the 60s, 50s, 60s, almost every home and business had a location that you could escape to, fallout shelters, because of a threat that we had at the time. So again, we have that threat as a military base because we're a target for an enemy to hit us. So we have to think through that about how we can survive. Okay. That is combat engineering. That's one of the elements, one of the three elements of this military engineering. Then there's the general side, and the general side really does pull in all of that stuff we were talking about with civil. We have to build installations. So if you think about a military, like the Air Force specifically, we launch and recover aircraft, right? We fly planes. We're in the Air Force. So we fly planes. Can I fly a plane from anywhere in the world? What do I need? Think through that real quick. Talk to yourselves, and you put down at least one thing we need to launch an aircraft. Absolutely. Thank you. I don't know if that was actually Mike. I see Mike Lance is what's written there. Okay, great. That is exactly what we need. He put runway. Yes, you have to have a runway. That's a long strip of pavement, and there's a whole lot that goes with it. There's lights that go with that. There's a navigation gear. There's a tower. There's support infrastructure. As an engineer, that's what we use to launch our defense. So anything that we have in our defense mechanisms in terms of stopping bad guys from hurting people around the world, in terms of the Air Force, we have to have infrastructure. So that general engineering, I have to build runways. I have to build buildings to maintain our airplanes. I have to build places for them to be protected. So that's where we bring in that construction side. We bring in the environmental side, because if I'm doing things that can potentially damage people or infrastructure, that comes with hazards. And I've got to think about how can I take care of these things and still take care of the Earth that we have. We only got one Earth. If you've seen the shot from space, it's a little marble and a whole lot of black. Okay. So it's the only place we've got to do this. So we got to make sure we take care of that. And so that's kind of what that general engineering aspect of military engineering takes care of. It's providing the infrastructure that supports the people, that supports the assets that we have, the weapon systems like an aircraft. Maybe that aircraft's going to be used for cargo. Maybe it's going to be used for refueling. Maybe it's going to be used for as a fighter or a bomber. Okay, so there's lots of different things. We do search and rescue. Lots of missions that we do. We have to provide infrastructure or civil engineering or buildings and all these things that can allow us to do that work. So that's the general. Then the geospatial side, really cool stuff. It's all about terrain. If I want to go in, if I was asked you to go find a certain location, what would you need? What would you pull out if I go ask you to go find a certain location here in Ohio? Okay, a map for sure. How many of you would pull out a phone and use like Google Maps? Yeah, all of you, right? That is linked to GPS, Global Positioning System. And it's the satellite system that allows us to understand where things are in the earth. Okay, we use that same type of information and we use it for a lot of really good detail to understand where things are. That is an aspect of military engineering that allows us to make good decisions. So whether or not you agree with a lot of the things that happen, that is one of the things that we use to provide us with information to make sure that we're making good choices so we can track things. So one of the mission sets that I did down in Africa is I supported drones that were basically going up and they were just taking pictures. They weren't there to do anything else except for take pictures and survey people, because there's a lot of bad actors in Africa that were taking drugs and terrorism and criminals, and they were transiting across the space of Africa that we were monitoring. And so I'm an engineer. I wasn't doing the monitoring, but I'm building this runway and infrastructure so they could launch and recover these aircraft that could then go over and watch these caravans taking drugs, taking weapons to feed insurgency that was then creating violence in certain areas across the world. As we did that, we then had another team that would stop them. We'd go, hey, this is what we got. We've got pictures of them. Here's where they're going. Here's what they're doing. We'd send them this geospatial information, and then they would send in somebody to stop them. It was incredible what we were able to stop. You see the reports, and you're like, oh my goodness, we just probably saved thousands of people's lives because of what we just stopped going in there. So kind of a neat thing that we did, but that's all I want to talk about right now, because I want to turn it back over to you. What are some questions that you have, either about military engineering or about any other aspect that we've kind of covered today? If you raise your hand, we can unmute you. You can ask your question, or you can type it in, whatever you feel more comfortable with. I see your hand. Go for it. Elijah Mays, I guess.
What aspect does like computer programming have to do with geospatial engineering?
That's great. Good question. So a lot of the geospatial stuff deals with computer programs and software. And if we wanted to use any sort of algorithms that will help us identify things, that's when we'd have to use computer programming in that context to make it help us process more data faster. We can all look at a picture and pull information out, but if I can have a computer pre-sort things or tell me what's changed from time A to time B, hey, vehicles moved this far, it's going this fast, it's heading this direction. All of that has to have computer code underneath it to then allow me to understand the information that I should be able to see from that picture. Does that make sense? So that's kind of how that links in, and it's under everything there. So all of your software programs, which we use, which are a lot of different ones, all of that has to have computer code to build those software packages, but then also to provide you all the cool features that those programs can do. Great question. I see your hand. Go for it.
What's like a good kind of engineering to go into if you're like not good at math?
Yeah, that's great. That's a great question, right? So a lot of the engineering disciplines, it depends on what aspect you're coming at it. And there's a lot of people involved in engineering that are not necessarily an engineer. I would say probably architecture is a good one. And you say, that's not engineering. It interfaces so much with engineering. It's one of the ones that are very, very common. Okay. There's also a lot of other aspects to engineering. Yes, you need to know the mathematics, but a lot of times there's a lot of helps and things. So one of the things, for instance, I did in environmental engineering is I was a field tech, and I went out and I took water samples. I was out on a river most of the days. When I wasn't in school, I was out on a river or on a lake, and I was taking water samples, and I brought back to the lab, and I was doing like tests on them. I had to have some basic math. I had to understand basically algebra, but nothing much past that. Now, to get to that point, I did have to take some higher level math, but I wasn't using it on a typical day. I was mostly doing this minus this, or let me deal with some units. So I have to times this by this to make sure the units convert correctly. So not substantial, but yet I had to at least understand and appreciate other math before I was using that level of math. Does that make sense? So I think sometimes we're intimidated by that, but there's jobs that you can do in engineering that you're using that math every day, like complex, hard math every single day. And then there's other ones that you're using like basic linear equations of like, hey, x plus y equals z. And you're like, okay, I can handle that. You give me x, you give me y, I can give you z, or you give me z and give me x, I can find y. That's most of it, honestly. Honestly, the vast majority of what we're doing is simple things like that. So hopefully that helped answer your question, but good question. So I'd say almost, so to go back on that, every discipline you can do that. There's pieces of that. I would say good ones though are probably environmental engineering, industrial engineering, computer engineering, or more like kind of something like more code, those types of things. So, okay. What are the questions you got? Are you all going to college? So I'm like, I don't know. And then a lot of head nodding. Great. So I want to let you know one thing, okay? So in college, here's my take on this. Study what you love, because I think you'll do better at it, and you'll find that you enjoy it. It won't be a burden to do your homework if you love it, okay? So I would encourage you to do what you want. And then also, I hope that no one would feel like they don't have the means or the opportunity to go to college because of finances or because they don't think they're up to it. I encourage you to go if that's something you want to do, because there are people that are willing to bend over backwards to help you. When I went, I was so impressed by how many outlets there were for people to provide support. Now, maybe that support with homework, and that support with finances. I came from a poor family, and I was able to get through college with in-college scholarships and other things. And I was like blown away with how much money was out there if you go looking for it. So I'd encourage you that if that would not be an obstacle.
I think we've got about 4 minutes left. I don't know if they have any other questions. I think we enjoyed it a lot. Do you guys like it? All right. Thank you so much. It was very informative.
Yeah, no problem.
And I think, are you doing the other 2 classes today as well?
I'm going to do one of the other classes.
Okay.
So we'll see if they choose military engineering as well, if they go a different direction.
Yeah. So thus far they've done mechanical and civil. And we're going to start electrical soon.
Oh, very good. Very good. And so one of the things really interesting there is, as we talk about civil engineering, if you think about that, yes, we deal with buildings, but we also pull in mechanical engineers. So we deal with HVAC systems, which is heating, ventilation, and air conditioning. That has to have a mechanical engineer to talk about thermal cycles and understanding of heating and cooling. Then we bring in electrical engineers because we provide power to people. So it's really interesting. It's almost like an integrator of a sense that we have to pull in so many different people to provide the services that we as people enjoy. And that's what civil engineers do. We provide you a city. We provide you a life, that civil infrastructure that you use every single day. Drinking water, wastewater, power, communications, all of it comes. So awesome. Well, thank you so much. It was great to talk to you all. Have a great day.
You.